Good morning, Year 10. In this video, I'm going to go over the answers to the 5 questions from Term 3, Week 8 for Tuesday. I already recorded this video, but no sound came through, so I'm just going to talk about my answers. So for question 1, we need to use the sine rule, and we're trying to find the sine rule, use the sine rule to find the side. So I'm going to put the side on top and the angles on the bottom. So they have to be all the angles on the bottom and all the sides are on top. Okay, so I've put into the sine rule. So I have x over the opposite angle, and then 13 over the opposite angle of 28. And I want to get x by itself, so I'm going to times both sides by sine 42. When I do that, I get this expression. If I type that into the calculator, I should get 18.53 meters to 2 decimal places. For question 2, it is basically the same. It's still a sine rule because we have opposites. So that's why I've highlighted them with the same thing here. But what I need to do there is I need to put the sine, the angle, on top of the fraction. So here's the angles on top and the sides are on the bottom. So the first thing I need to do is do sine theta over the opposite, which is 17. And then I do 35 over the opposite, which is 136 degrees. And I want to get sine theta on its own, so I'm going to times both sides by 17, which gets rid of this. Then I get this expression here. Now what makes this different to the first one is I need to do the inverse sign. So that's the shift sign in your calculator. And you put shift sign all of this, so it should look like that when you type it in. And when you do that to the nearest degree, you get 20 degrees. For question 3, we need to solve 2 cos theta equals 1, and that's between 0 and 360 degrees. So that means we need this all stations to central situation. Now, we want to get it so it's cos theta on its own. So I'm going to divide both sides by 2. And when I do that, I get cos theta is equal to a half. Now, because cos theta is positive, we want the positive numbers for cos to be in the first and the fourth quadrant. To get the first quadrant, we just need to get theta. To get the fourth, we need to do 360 minus theta. So let's do the first one first. Inverse of cos for a half, so that's doing the opposite, just like we did question 2, gives us 60 degrees, and that's in the first quadrant. Then we need the fourth, so I'm going to do 360 take away theta. In this case, theta is 60, it's the number we just got. So our fourth quadrant angle is 300. Now you can put that back into the calculator for both, just to check. So if you typed in cos 60, you will get a half. And if you type in cos 300, you'll also get a half. So that's a way you can check your answer. Next, we've got to solve log base x 27 is equal to 3. Now, because of this, we've got our base, answer, and power. That's the BAP form. And we want to rearrange it. So I put my base here, my power here, and my answer here. Now, to get the x on its own, I need to do the opposite of the power of 3, which is the cube root of 27. So that's what I've done here. And when you type that into your calculator, you will get x is equal to 3. That's the answer for that one. Last up, we need to find the area of the triangle below. But we need to find h first. So we know the area of a triangle is equal to a half times base times height. But we don't have the height. But we do have enough information. So the information that we had was the 20 meters and the 12 here. So using this angle of 30 degrees, which was given as well, I'm going to label the triangle opposite, hypotenuse, and the answer, and the adjacent, sorry, the adjacent. So for sine theta, we're going to do opposite over hypotenuse. So that's the angle's 30 degrees. The opposite is h for the height, and the hypotenuse is 12. We want to get h on its own, so we're going to times both sides by 12, and we get 12 sine 30. So instead of just figuring out what that is, I'm going to replace h in our formula here. So we've got our half. Our base is 20, so that's our whole base there, is 20. The height of the triangle is then 12 sine 30, and you type that all into your calculator and you get 60 meters. Now this is a proof for what we're going to learn today, but I just wanted to show you how it works and where it comes from, because we're going to look at the area rule for non-right angled triangles. Talk to you then.